If point O is the center of the circle and angle OAB is 30 degree, while length OC is 18, that is the radius of the circle. In order to find the arc length AB, which is radius times the angle of arc. Radius is given to us, that is 18, so we just need to find the angle theta. Now length OA and OB are same, as both are the radius of the circle, so the angles opposite to same length sides will be same. Subtracting the two angles from 180 will give us theta. Now angle theta needs to be converted into radians by multiplying it by pi over 180. Finally, arc length is calculated by multiplying angle by radius. For the given circle with a center at O, if the arc length ADC is 5 pi and angle x is 100 degrees. To calculate the arc length ABC, we can first find the measure of the angle the arc ABC makes by subtracting 100 from 360. Next, as the radius is the same for both arcs, we can equate the ratios of arc lengths to their corresponding angles. Simplifying the expression give us the arc length ABC, that is coming 13 pi.
Ever wondered how to find the slope of a line tangent to a circle? Let's figure it out in this problem together. Here we are given the coordinates for the center of a circle at -4, -6, while line K is tangent to this circle at the point -7, -7. In order to find the slope of this line K, we can first calculate the slope of the radial line, which can be calculated by taking the difference between the y components of the two extremes of the radial line and dividing it by the x component, that is coming 1 over 3. Next, since tangent line K is perpendicular to the radial line, the slope will be negative reciprocal of the slope of the radius, that is coming -3. To figure out the coordinates of the center of circle for the given equation, we can start by writing the general form of equation of circle. Here, h and k are the x and y coordinates of the center of circle. Next, we need to convert the given equation into a form similar to the general equation, which can be achieved by completing the square method. For the term x squared plus 20x, since 2 is multiplied by 1, that is the coefficient of x squared, and 10 to get the value equals to 20x. So we need to add 10 square on both sides. That will be 100. Similarly, for y squared plus 16y, 8 square needs to be added on both sides. That will be 64 to complete the square. Finally, comparing the two equations, we get h equals to -10 and k equals to -8. Those are the coordinates for the center of circle. If a circle has center at point O and point A and B lies on the circle, and the measure of arc AB is 45 degrees while the length of the arc AB is 3 inches, in order to find the circumference, we can start by first figuring out the radii of the circle, which can be calculated using the formula S is equals to r theta, where S is the arc length, r is the radius, and theta is the angle of the arc. Now, for the circumference, we can apply the same formula one more time. Since the theta for the circumference will be 360, plugging in the value in the formula, we get r equals to circumference divided by 360. Comparing the two values of r, we can solve for the circumference, that is coming 24. If a circle has a diameter with endpoints 2, 4 and 2, 14, and we need to figure out the radius for that circle, we can solve this problem using the graphical method. We can start by plotting the endpoints on the graph that will be the diameter of the circle. Next, from the general form of the circle equation, we can extract the coordinates for the center, that is 2, 9. Now for the radius, it will be the distance from the center point to the end point. That is 9 minus 4 equals to 5. If a circle has a center at point O and point R and S lies on the circle, and we are given the angle ROS as 88 degrees, in order to figure out the angle RSO, we can note that the two sides OR and OS are basically the radius of the circle. So the angle opposite to these sides will also be same. Next, we can use the properties of internal angles of the triangle that their sum is equals to 180. Simplifying will get us the value of angle RSO, that is coming 46 degrees.
The graph of the given equation is a circle. In order to find the radius, one way is by converting the given equation into the journal form of equation of circle in the xy plane. The term x minus h squared can be obtained by adding 1 over 4 on both sides of the equation to complete the square. Y minus k squared can be obtained in the similar fashion. Finally, simplifying the right-hand side of the equation gives us the radius of the circle. Or you can just write the given equation in the graphing calculator provided during the SAT and measure the distance on the graph to get the radius. Which one would you prefer? If a circle on the xy plane has a center at point negative 1, comma 1, and line T is tangent to the circle at point 5, comma negative 4, in order to figure out which of the four following points lies on the line, we can start by plotting these 2 points. Distance between them is the radius of the circle. Next, we can draw the tangent line T at point 5, comma negative 4. Now, slope of this tangent line can be calculated by first calculating the slope of the radial line, that is coming negative 5 over 6. Since line T is perpendicular to the radial line, the slope will be negative reciprocal of it, that is 6 over 5. Once we have the slope, we can calculate the intercept to write the equation of line T, that is coming y equals 6 over 5x minus 10. Finally, we can plug in the values of x to see if it matches y for the four given points. So for point A, if we plug x equals to 0, y will be negative 10. So that won't be our correct answer. Next, if we plug x equals to 4, it gives the y equals to negative 5.2. That is also incorrect. Finally, plugging the value of x equals to 10 give us the value of y equals to 2. So this point C lies on the line T. For the given equation of the circle, if point P lies on the circle having coordinates of 10, comma negative 5, and PQ is the diameter of the circle, then in order to find the coordinates of point Q, we can start by getting the center of the circle from the equation, that is at 6, comma negative 5. Since center is in the middle of line segment PQ, we can add the x coordinates of P and Q and divide it by 2. That should be equals to the x coordinate of the center. Simplifying will give us the x coordinate of point Q. The y coordinate can be calculated in the same fashion. For the image of the circles provided to us here, we are given that point D is the center of the medium-sized circle and the large circle shown here. In addition, we are given that the diameters of the small circles that are centered at B and F is equals to the radius of the medium-sized circle. So I have the diameter of this small circle here that is equals to the radius of this medium-sized circle present here. Now, in order to figure out what is the shaded area percent to the largest circle, we first need to figure out the areas of each one of these circles. So let's start this problem by assigning some values to the radius of this smallest circle here. So let's say I have a radius of 1 here, and this guy will be also 1. Now, in the question, we are given that the diameter of this small circle is equals to the radii of the mid-sized circle. So the radius of this mid-sized circle will become 2. I have 2 here. Similarly, I have 1 and 1. Okay. Now, what we are looking for is we are looking for the percent of the shaded area. So basically, shaded area divided by the total area of the circle. That will be our big circle. And to calculate the percent, multiply by 100. We are looking for this specific value here. Okay, so let's solve for the shaded area here. So for the shaded area, we know that it can be calculated by subtracting these 3 circles from the bigger circle here. So let's start with the area of bigger circle. That will be pi r square. That is the radius. Now the radius of the bigger circle is this distance. That is 2 plus 1 plus 1. So this will be equals to 4 square. Subtracting the smaller circles I have here. So start with this one. I have pi r is 1 here, so 1 is square. I have another one, so pi 1 is square. Finally, I have the middle one, this guy. This will be pi 2 is square. Okay, so simplifying this, it will become 16 pi minus pi minus 5 minus 4. pi, that is equals to our 10 pi. This is the shaded area present here. Now the total area we have already calculated, that is our 16 pi. That was the area of the biggest circle. So total area I have is 16 pi. Now to calculate the percent shaded area, we just need to plug in these values in the expression above here. So let's do that here. I have my shaded area, that is 10 pi, over the total area of 16 pi times 100. So if we simplify this, this will become, pi will cancel out. I have 5 over 8. So 5 over 8 times 100, that is equals to 62.5.
Can you figure out the diameter of the eye of the storm in the xy plane given by the following equation?